So I hope everyone will be fine during this COVID lockdown period, right? So being at home, let us try to learn something, okay, a concept by taking some activity, right? Right? Let us take one activity. Let me show you, right, some model. There is no need to go to laboratory, and we can do also at home by using the materials available. Let us have a look into this, right? I will show you two different things, right? I have shown you what happens two glasses, and the liquid is nothing but water, and what happens you see in the first one, right? Here the glass is there, water is there inside, and the two rods are there, right? What are those rods? I have used here, those are called as graphite rods. What is the graphite rod? You are acquainted with this graphite rod, right? Right, what happens, you are using the pencil, right? In the pencil this graphite lead is there. This is what your graphite rod is. Do you see any change here? See, around the two graphite rods, these graphite rods are called as electrodes. Can you see any change around any of the electrodes? Surely there is no change at all. Simply what is visible? The two rods has been dipped in water. There is no change around any of the electrodes, right? Now let us come to this. If you look into this now, let us have a look into this glass beaker. Any change is there here, right? What is visible there? Definitely there is a change. What change is there? You see, around the two electrodes, this is one graphite rod, this is another graphite rod. Around the two electrodes, some gas bubbles are coming out, right? It's clearly visible. And again, if you see, more bubbles are coming out here as compared to here, right? If you want to more, what happens, the more visibility, let us have a look into, I am touching both the electrodes, have a look into this, right? You see, what happens, the gas is producing more and more, right? Because now at the two electrodes, the gases are produced, but when now I mixed both gases are produced combiningly. That's why the production is more, right? But the change is what happens, I told, some gas bubbles are coming out around the two electrodes, right? Why? You see, I have connected one battery to the two graphite rods or to the electrodes. What is the role of a battery? Battery supplies electricity or electrical energy, right? You know very well this, right? So battery supplies electricity or electrical energy. Now when electrical energy is supplied from the external source, that's a battery, to the water, right? Then you see around the two electrodes, some bubbles are coming out. What are those bubbles, right? Then you will understand it. Again, why more bubbles are coming at this electrode? What is this electrode or what is this side? If you carefully look into this battery, you see in this side it is called as the negative sign is there, negative pole, right? So the graphite rod which is connected to the negative side, at that electrode the bubbles are more as compared to the what happens, the other graphite which is connected to the positive pole of the battery, right? Again we will try to understand why the bubble is more as compared to here, right? So at a negative pole means what in a battery, that's called as cathode. The positive pole means called as anode. So now at the cathode the bubbles are more as compared to the anode. Got it now? So now we understand what is this concept, why the bubbles are produced and why more bubbles are produced at a cathode compared to anode, right? So what is this concept? Let us try and we will understand, right? So what is the requirement for this? You need one battery, you need one like liquid through which electricity can pass. I have taken water, also salt water can be used, right? And two conducting path. Conducting path means you can use any metallic rods, right? Any metallic rod through which electricity can pass. They are called as electrodes. They act as a conducting medium. Got it? Now let us come to, you saw now the activity, right? Now let us try to understand what is happening. Now if I say, can you break this earbud? How to break it? Either you have to apply some force, right? As it's a plastic, it may not what happens break by applying force here. What I do also, when I cut it, also applying by I am applying force. Now I will cut it. See, it's broken, right? So now these physical matters like maybe a stick, or you can by take a chalk, you can break it easily. Now if you, my question is, can we break the water? Can we break the water just like I cut the stick by using a scissor? Can you cut the water by using a scissor? Can you break it by using a knife? Or can you break it by hammering by a stick or by a hammer? Definitely answer is no. None of the method can be applicable to break water. What is the meaning of a breaking water? As I told here, I broke the bird into two different pieces. Again also I can cut it into two different pieces. But now, can you break water? Let us come to this. If I say now water, what is the molecular formula? Molecular formula is water, that is present in the liquid form. Right? Now, actually the shape of water is V shape. This is the shape of water. But for your understanding, let us take it as it is linear. Right? Take the linear form. Now, if I want to break it, what is the meaning of a break? It's a chemical. It's not it. What is nothing but a chemical? What happens now? If you want to break it, you have to break these bonds. Right? This is called as a decomposition. Right? If you are breaking a chemical compound, right, you can use the water decomposition. So, if you want to decompose water, what you have to do? You have to break this bond as well as this bond. Right? And just as before I told, can you break this bond by using a scissor? Can you cut it? We cannot. Now, how to break this bond? Okay, as we will discuss later. Now, if this bond is broken, what we will get now? Let us see. Now both are broken. We will get 2H and 1 O. Right? So what happens? We will get 1 O plus 2H. Is not it? 2H is there, 1 O is there. Now try to understand this. When the bond is broken here or the water is decomposed, we get 1 oxygen, 2 hydrogen. As you know, oxygen and hydrogen, they exist in the nature by gas, in the molecular form. They do not exist in the atomic form. Now these are the atomic forms in which they do not exist. That's why they will go into their which form? Gaseous form. What I write now? Gaseous form, half oxygen gas. 1 oxygen atom means I divided 2 for 2 oxygen atoms. That means it is 1 oxygen atom. So now oxygen goes to gaseous form. But all over it is 1 oxygen atom, but present in the gaseous form. Another is here 2 hydrogen atom. It exists in the gaseous form, that is H2 gas. That means when water is decomposed, it gives rise to oxygen gas and hydrogen gas. Clear now? Another point come to now. Now if we look into this quantitative aspect, I told you here 1 oxygen atom, 2 hydrogen atom, means the liberation or production of hydrogen gas will be twice the production of oxygen gas, because its quantity is 2 times than the quantity of oxygen. Is not it? That means the liberation of hydrogen will be more or 2 times as compared to the liberation of oxygen atom, or sorry, oxygen gas. Right? Now you understood the decomposition of water, what is the product. But the question is now, how to break this bond? How to break this bond? Now come to the concept electrolysis. Right? Now come to this. We will discuss how to break this bond. So now what happens here? The concept now comes as electrolysis. By using the process electrolysis, we can decompose water. Now then, what is this concept? What is this? Let us understand. Actually, for this electrolysis, we are using one battery. Already I have mentioned one battery is used, which supply electricity or electrical energy. Now, around the year 1800, right? For first time, the battery was invented by Alessandro Volta. Alessandro Volta developed the first battery, that is called as voltaic pile. See, this voltaic pile is nothing but a battery. Okay, what is the battery? Battery, I told, for example, we can present like this. It's a battery, and one end is called as positive pole, another end is called as negative. What is this negative pole? Is called as a cathode, and another end is called as a anode, which is positive. So what happens now? Around the invention of the battery, now what happens in the same year 1800, right? Another what happens authors, this is nothing but William Nicholson and his co-author, what they did, they took this battery, right, and the two poles are visible here. What they did now, they connected the two ends of the battery by two wires. Then again what happens, the two wires, they dipped in water. So here what happens, water is there, liquid, right? What these authors they did, they took the battery and to the end of the battery, they connected through wire, and the two ends of the wire, they dip inside the water. And what they found, around the two rods or electrodes, gas bubbles are coming out. The gas bubbles are coming out. And after experiment, they found that these two gases are nothing but hydrogen gas, and another is oxygen gas, right? Now then the term came electrolysis, right? Now the term, what happens, the term it is as a electrolysis. What is the term? Have a look into critically here. Electrolysis, let us break into this word. One is called as electro. Let us take it as electro, another is called as lysis. What is electro? Right? Electro means what? Electro stands for electricity or electrical energy. What is the lysis? Lysis means what? Decompose or break. So what is the meaning of electrolysis? Decomposition of any electrolyte. Electrolyte means what? Any substance present in the molten state through which electricity can pass. So the decomposition of a chemical compound or electrolyte by using what? Electricity is called as electrolysis. So electrolysis is nothing but a decomposition process of an electrolyte by using electrical energy or by using electricity from external source. What is the external source here? Your battery. Got it? This is what the electrolysis concept came. Now let us see what are these gases, how it is produced, and we have some questions. Why, at what electrode which gas is produced, and why it is one gas is two times than the other gas. Let us try to understand that concept. So now let us take it. What happens for the electrolysis process? What are the requirements? Already told. This glass vessel, right? We call as a electrolytic tank, right? This is called as electrolytic tank. So this is your electrolytic tank. You can write it here as electrolytic tank. Now what happens? In this you take water, right? So what happens? Here water is there in the liquid form. Now what you do? Take the battery right? It has two poles, positive and negative. This part is called as cathode and the positive part is called as anode. Now the two ends, right? You connect through wires and try to dip into the water, right? So these two wires is nothing but your graphite rod. What I have used here, this is what happens the graphite rod, right? Already I told this is available in your pencil also, right? So here the two rods here is nothing but a graphite rod and they act as a conducting medium, conducting a path through which electron can move, right? Now when it is dipped inside water, now the water breaks into ions. What are the ions? It gives rise to H plus ion and OH minus ion, right? When water breaks, it gives rise H plus ion and OH minus ion, right? This is hydroxyl ion. This is called as a hydrogen ion, right? Hydrogen ion. Now what happens after this, right? I am explaining here now. I am erasing it. So here now, as I mentioned here, this is two ions are produced by breaking up water, right? When electricity is applied. Now what happens? What is the anode? Cathode? Cathode is negative. Cathode is negative. Now as it is negative to the negative plate, then the positive ion will move. Opposite ion. Opposite charge means ion carrying opposite charge. So it moves now H plus ion move here. So now when H plus ion is moved, right? Then the H plus ion reach here and take the electron from the, because negative source is there. That's it, take the electron and get neutralized. What happens here? Now the H plus ion reach cathode, take the electron from the cathode and goes to hydrogen atom. Now two hydrogen atoms combine and they produce hydrogen gas. As it's a gas, that's why the bubbles are come out at what? Around cathode. That's why around cathode hydrogen gas is produced. That's why the bubbles around the cathode is nothing but which gas? Hydrogen gas. Clear now? Now come to the anode part. Now it will go to anode, right? In the anode what happens? That is a positive plate of the battery, positive side. As a positive side, that's why the negative ion moves to the anode. The ion having opposite charge to the anode. Now what happens here? OH minus ion move to the anode. And what does it do? It release the negative charge means electron to the anode because this is positive. What happens now? It goes to OH, right? Then what happens? Two OH combine, right? Two OH combine to give rise to water liquid, and if we see, if the water liquid is gone, H2O, then one oxygen atom is left. I told oxygen does not exist in an atom. That's why it exists in the form of water. Oxygen gas now. So now the oxygen gas is produced at what? Anode. That's why at anode now oxygen gas is produced. That's why the bubbles around this anode is nothing but which gas? Oxygen gas. Right? Let me show you once more here. If you look into here now, see. So this is what in the battery, this is what happens negative, and this is your positive plate. In the negative what happens? The products now here is more as compared to here. So here what happens? This is nothing but your hydrogen gas, and this is nothing but your which gas? Oxygen gas. Right? And why it is more? Let us come to here. Already I mentioned. At the beginning I mentioned when one water molecule undergoes dissociation, it gives one oxygen atom and two hydrogen atom. That means it is half oxygen gas and this is hydrogen gas. This is 2 times than the oxygen. That's why the cathode, the bubbles are more as compared to anode. Got it? This is what the principle of electrolysis. Right? And why the bubbles are formed? When electrical energy is applied. Right? So this is what electrolysis of water. That's why electrolysis is nothing but decomposing an electrolyte by applying electricity. Got it? So this is what all about the concept electrolysis. Right? Now, what is its application? Why to study it then? We should understand that. It's not it. So anything which there is no use of the mankind, why will study that? So now let us see what is its application in our day-to-day life. That's what we are concerned. How this concept is being used in our day-to-day life, in the routine work. Let us see. So now come to the application part. Right? Come to application of electrolysis. Application of electrolysis. Now I will give you 2 or 3 applications. That is actually day-to-day life applications. The first one, let me tell you, it is found in application in the like metal industry, metallurgy. That is what happens. Extraction of a metal. Extraction of a metal. Basically, the metals which are highly reactive, right? Other methods are not suitable to extract it. To extract means to get the pure metal from its ore. What happens? The ore is there of a metal. From the ore we get the which metal? Pure metal. The process is called as what? Extraction. Right? Now what happens? Ore means what? This is nothing but a compound form of the metal. Ore is nothing but what? Compound form of a metal. That means it is the impure form. That is which form? Impure form. Now from the impure we will get the pure metal. The process is called extraction. But more chemistry is there. Okay. So what happens in the extraction of a highly reactive metal, the electrolysis process find application. I will give you a little bit idea about this. So for example, I will take, let us, bauxite. Bauxite is nothing but the ore of aluminium. Ore of aluminium. Right? Now this aluminium is present in a compound form. The common name is called as what? Bauxite. Now that means bauxite is nothing but the impure form of aluminium. How to now extract pure aluminium from this? That means from bauxite we should get a pure aluminium. I will give a rough diagram. So here what you do, same thing. Take one electrolytic tank, right? What happens? Similarly put 2 electrodes and put your bauxite, which is nothing but the ore of aluminium. Now when the electrical energy is applied from a battery, right? From a battery, then what happens? This is the liquid form. Bauxite is present in the liquid form. Now what happens? Aluminum also present in it. So what happens? Aluminium 3 plus ion is produced from this. Now as it is positively, then what happens? Also you know the battery has 2 ends. Now as it is a positive ion, it will move to the cathode. Right? It will move to the cathode. That means from the impurity or impure bauxite, now pure aluminum get deposited at what? Cathode. That means you got the pure metal now from the impure one. What is this process? Electrolysis. You are purifying it by applying electrical energy. This is one application. Similarly, sodium also can be extracted, magnesium can be extracted because of highly reactive metals. Right? Now this is one application. The second thing I am giving, the second one is okay. The second application is, for example, now corrosion protection. The second is called as a corrosion protection or prevention. Corrosion protection. What is corrosion protection? If you look into, for example, some iron metal. Okay, if I do have some iron metal, let me show you just a minute here. Some iron metal. Yeah. Let us see this iron. Now you see, is it the original color of iron? No, absolutely no. It's not it. When iron is extracted, this is not the original color. You see a reddish brown color is on the surface of the iron. So this reddish brown color is called as a rusting, right? This is called as a rusting of iron, right? So this reddish brown color is nothing but your iron oxide, and this is nothing but the rust. Now if you want to protect this iron from rusting, right, then what you can do, you can cover its surface by another metal, right? You can cover its surface by another metal. That means now the metal is protected. The metal is protected. This can be done by electrolysis process. Let me tell you how is it, little bit idea. Let us see, as I mentioned before, for example, these are the two electrodes. This is your battery and it is connected here like this. This is positive, this is negative. Now if you want to protect this iron, make this iron, this is nothing but your iron. You want to protect it, iron to be protected. Iron is to be protected. Now that's why take this iron and take as a cathode negative plate, connect it to the negative end of the battery. Got it? Now what happens, you can take the any other metal as the anode. You can take any other metal as the anode. Now what happens, what is that other metal? Basically the metal, right, which is to be coated over its surface. And this electrolyte or solution must be a solution containing ion of this metal. Got it what I told? That means this is the iron rod to be protected. This is one example. Let us, this is your other metal which is to be covered over its surface, and this liquid is nothing but an electrolyte containing the ion of this metal. Got it? Now when electricity to pass through this, got it? When let us, this is your metal is M, this is your iron. Now when electricity is passed through this M goes towards M plus ion. As it is positive in nature, it moves to the cathode, right? Because it's negative. When it moves here, this metal comes here and take the electron from here and get neutralized. That means M plus goes to cathode, take the electron and convert into neutralized metal. Now this metal, what happens? Deposited over the iron surface. Once the entire iron surface is covered, now you stop the process, your iron is protected. This is what corrosion prevention. So now what you did, what happens, cover the surface of iron by other. That means a metal is there, it is covered by another metal. I am showing this. This is your base metal. This is what happens, the other metal which is on the surface. Right? When one metal is coated over the other metal by this process is called as a electroplating. Okay? So this is the second application. Now the third one. So the third application is like to make any metal surface attractive. To make any metal surface attractive. What is attractive? Attractive means looking good appearance. Right? Example, sometimes now in the commercial market, you will go to jewelry shop. No doubt the gold ornament is there. But sometimes what happens, the other ornaments, they cover it by other metal, like gold. Is not it? So to make attractive to the people or appearance good, then what happens? This electrolysis process is used. Already I mentioned the same process is being used. Just in the previous method application I told, same method can be used. This is what the third application, right? To make the appearance as good. This is what all about the concept electrolysis and what its applications.